All right, everyone. Hello. Welcome to my channel. My name is Thomas, and I am uh, dedicating my channel to educational matters. And um, we just got done going through the book Beyond Space and Time by Dewey B. Larson. And that was kind of getting into his metaphysical theory of his reciprocal system of theory. The reciprocal system of theory is a theory of everything that Larson derived during the 20th century up until his death in 1990. And most of his earlier work is on the hard sciences. We just went through his last book, Beyond Space and Time, that's more on metaphysics, religion, philosophy, and psychology. Um, Now we're gonna back up a little bit. Eventually, we're gonna take a look at his stuff that is on the hard sciences. Maybe not in as much detail, but in some good detail. But today, I want to back up, or for the next few days, back up and kind of look at the man himself and what his motivations were, where he's coming from, what his background is, what the context is, um, and what's at stake. And so we're going to take a look at his 1984 interview that he did with Jan Sommer in Salt Lake City, Utah, August 1984. And at this time, Larson was already, I believe, 86 years old. This was just 6 years before he died. And he was in the middle of his most productive period, really. Uh, he did his great work, The Structure of the Physical Universe, Volume 2, or the revised version of that, which includes three books. Um, Nothing But Motion, which is mainly physics, Basic Properties of Matter. I think Nothing But Motion is from 1979. Basic Properties of Matter, which is on chemistry, 1987. And then his book on astronomy, Universe of Motion, 1984. Those are kind of his three major works on the hard sciences. And then he did his Beyond Space and Time during that same period, but it wasn't released till after he died. Um, Again, with the reciprocal system, the basic idea is that the universe is not a universe of matter, not a universe of energy, but it is a universe of motion. The and motion is the relationship between space and time. When you use that term relationship, you're kind of implying this reciprocal relationship. Space and time are reciprocals of one another. They don't really exist, they only exist together in motion. And all of our basic phenomena of science are forms of motion, and they are relationships between space and time. And unlike the kind of the legacy science viewpoint where space and time are the container of the universe, we see space as this empty thing that we are, contained within. Larson sees space and time as the actual contents of the universe. The universe is made out of this relationship between space and time, or motion. He uses the term motion most often, but he originally started by using the term space-time. And that he's also used the word change in three dimensions, because as reciprocals, whatever qualities refer to one also refer to the other, space and time. So space we know to be multidimensional, three or more dimensions. Therefore, time also is three or more dimensions. We know of space, we know of time to be flowing or progressing, always getting later and later. Therefore, Space is also flowing and progressing, always getting farther and farther apart, observed by the Hubble telescope in the recession of the distant galaxies. Larson calls that clock time and clock space. And then with the dimensionality, he calls it coordinate time and coordinate space. And then there's also the discrete unit postulate. Time and space only come in discrete units. It's not a continuous thing. It's chunks. They come in chunks of space and time. And one unit of space in one unit of time is the speed of light. And so, using that logic, the space and the speed of light is not the maximum speed of the universe, the way Einstein would have you believe, but it's the midpoint or the null point or the neutral point, the origin even of the universe. So that is another departure, and that is what kind of creates his ideas for the book Beyond Space and Time, where he says, well, half of the universe is actually moving faster than the speed of light, and half is moving slower, and that creates two different regions, which when they combine, that creates life. But most of his books don't go into that. So we're just going to be reading some of his comments here from his 1984 interview. And I don't know that I have written down all the questions from the questioner, but you can kind of get what those questions are implied from just Larson's answers. Okay. The fact that I'm steering the theory away from mathematics now is not because, as some might think, I have a dislike for the subject, but simply because I found out that you can't get to what I was after by that route. I graduated in mining engineering, not because I had any intention of doing mining, but because I only had enough money to get by for 3 years. General engineering. He won an award there at Oregon State University, where he went to school, and he was actually colleague, or he went to school at the same time, and was knew Linus Pauling, and so they were both given an award for like the brightest student or something like that. And he says, I don't think it mattered any more to him than it did to me. And he says, I've always been somewhat of a rebel. I got shoved into administrative work, as so often happens with engineers in industry. And that was one of the things that contributed to my going into the research work on the side. I wanted to tackle something specific of the rather first order of magnitude, so that if I did hit something, it would be worthwhile. Something I knew had an answer, or felt certainly had an answer, and yet nobody had gotten it. Then he goes on, we are not changing the mathematics or the physical equations. We're changing the view of the problem. And that's one thing that is kind of missed about the reciprocal system, is that when he talks about using the basic postulates of the reciprocal system to derive a universe of motion, 90% of what he comes up with already exists. It's already out there. It agrees with the legacy scientist. It's only 10% or something that is in disagreement with the legacy science. And that usually has to do with the realms of the very fast, the very slow, the very large, and the very small. So on the margins, in general, the Newtonian equations are correct when applied at kind of a macro, but not super macro level. And that was kind of the same finding that Einstein had. Einstein, adjusted some of the equations using some other mathematics like Minkowski and Lorentz contractions, but he left alone the majority of the Newtonian mechanics. It was just on the margins that these changes needed to be made. And that's kind of the same thing with Larson. He actually has a book that's called Beyond Newton. His work is not coming from beyond Einstein, it's coming from beyond Newton. Newton is the core of this, but Newton didn't get into the very fast, the very small, the very large, and the very slow. Okay, so here Larson says, we are not changing the mathematics of the physical equations. We're changing the view of the problem. In other instances, he talks about how that the equations and the legacy science, the science that we learned in high school and stuff, that the stuff, it's mathematically correct, but it is not conceptually correct. That's what Larson is changing. He's changing the underlying concepts of the numbers, but his derivations, where he derives the same equations as the classical mechanics, but it's that he's changing the view. He says the view of the problem, or the concepts underlying these numbers. Okay, so here he says, quantum numbers are the same kind of adjustable constants that they're putting in the equations of state. Each element gets a set of numbers not taken out of thin air or determined from experiment or anything like that, but from pure theory. And to the extent that we have arrived at equations such as that for interatomic distance, they are theoretically explained rather than quantitatively explained. So he's saying that the equations of quantum mechanics, they're correct mathematically. They make sense quantitatively, but they don't have the theory. They don't have the theory behind it. It's like they reverse engineered the theory. They started with the numbers and reverse engineered the theory. Now, critics of Larson would say that he did the same thing in a number of instances, and I would probably agree. Old habits die hard, I guess. But to a great extent, he also altered the concepts underlying the whole situation. Okay, I was trying to find mathematical equations in which numbers could be assigned to these different substances, exactly as the rest of them were doing. It wasn't going to get me what I wanted, because ultimately I am going back to a number that is arbitrary. What I had to do was to get something that is meaningful to start with and work the other way. And so now he's talking about his first book. The first version of the first book, it dates back to about 1930. Okay, so that's like 60 years before he died. So he's working on this whole thing for 60 years. Plus, that's, inspiring dedication. Never got any credit, never got any money out of the whole thing. So that's why he's one of my heroes, and also because he did all of his greatest work when he was in his 80s. So that's inspiring to me, thinking, I still have a chance to do something, in my life that is a lasting contribution, because I'm not in my 80s yet. I don't have to give up yet. Okay, now it dates back to about 1930. First chapters were probably written around 1930, and the last chapters right around 1940. Much like digging up ancient ruins, these works were not written for publication. It was written to keep my ideas in a coherent form. I had no intention at the start to go into a new theory of physics. I was tackling a particular problem. In a very large percentage of the cases, when I got the right view, I didn't need any mathematics. A simple harmonic motion is just as fundamental as a linear or translational motion. Okay, so like in Larson's universe of motion, he's really got four fundamental motions. You've got the linear motion, and then you have the rotational motion, and then um, you've got the linear vibration, and then you've got the rotational vibration. And these will come in 1, 2, or 3 dimensions. And then now he's throwing in this simple harmonic motion, which is basically a combination of the rotation. Uh, it's really somewhat of a rotational vibration, but it's really the simple harmonic motion is the sine wave, and so the sine wave comes out of a combination of a linear motion and at the same time a vibratory motion. So you got the vibratory motion going up and down, and you've got the linear motion just going straight. And so when you combine those, you get a sine wave, or what he calls a simple harmonic motion. Simple harmonic motion is just as fundamental as a linear or translational motion. You start out with motion, and motion as such can occur in different forms. You don't require anything to keep it going. Okay, so this is just like Newton's. I don't know which one of his laws, but uh, an object in motion tends to stay in motion. We kind of have to take out friction or gravity from the situation. If you're in a vacuum, if you push an object, it goes and it just continues to go. So motion is doesn't require anything to keep it going. Motion is you know is a part of the whole structure, or as Larson was saying, it is the entire. Okay, in the absence, same is true with rotation. In the absence of friction, you can rotate forever. And so now he's kind of he backs up and he's talking about the states of matter. And this is fundamental to Larson's theory, that there are 4 states of matter, maybe more, but 4 that we're going to talk about within this context. You've got the solid state of matter, you've got the liquid state of matter, you've got the vapor state of matter, and you have the gas state of matter. Now, you can talk about the plasma or condensates or something like that, but that's where Larson's coming from, and this is fundamental to his whole structure. In the solid state of matter, basically you have 0 dimensions that are free. In the liquid state, you have 1 dimension that's free. In the vapor state, you have 2 dimensions that are free. And in the gas state, all 3 dimensions are free. And we'll get into that, what is it free from, eventually, but we'll just say that for now. I decided to tackle the more complicated substances and work backwards toward hydrogen. So he starts with the numbers at the top of the periodic table when he's doing his investigations, as opposed to starting from the bottom with hydrogen. And he also starts with, I believe, the solid state of matter, which is more complicated than the gas state. So he's kind of working the other way. The gas laws, as we're using them, the properties of gases are actually the properties of empty space. The ideal gas is a gas that has nothing but empty space in it. We get to the properties of the substance itself, then you have to make the correction, make a correction. And you have to correct it down to the recognition of these things you already have in the solid to begin with. I realized I had to introduce a third number. The minute you get into three numbers in anything like this, your immediate reaction is, those must be dimensions. And then from that, you deduced the atomic structure. That is the question that's being asked of him. So that's what Larson does basically with the periodic table. Whereas in, for example, oxygen is element number 8 in the periodic table. For Larson, he boils it down to 3 separate motions, 2 alternating 2-dimensional rotations, and then one-dimensional vibration that can be positive or negative. Okay, so for oxygen, for example, oxygen is 2 primary 2-dimensional rotations, 2 secondary 2-dimensional rotations, and 2 negative 1-dimensional rotations. Okay, we're going to stop it now. We'll take over here starting tomorrow. Pay attention. I've got another video coming on my decode of the resurrection coming up later today.